what I have a very simple little contraption here. All it has, if you see this little propeller up here, the propeller is actually just connected to this little electric motor. And then the electric motor has 2 wires. These 2 wires are connected to these 2 little pieces of aluminum. So this is 2 little pieces of aluminum. If you pay attention to it, I don't know if you can see real well, there are no batteries or anything in here. You could actually connect a couple of batteries, a battery up to this, but right now there's nothing connected to it. And there is a switch at the top. If I flip the switch, nothing happens. I can spin it by hand, but nothing happens. The idea is if I can actually have one of these pieces of aluminum in hot water or warm, and I make the other one cold, heat is naturally going to flow from high temperature to low temperature. So I would have heat coming in. That would be my QH. It's going to go into this electric motor. And the idea is maybe I can get some work coming out of it. That would be the spinning propeller. And then I have heat going into a cold reservoir. So the idea of thermodynamics and heat engines is you just need something hot and something cold to get this to work. So that's what I'm going to kind of demonstrate real quick. And I want to see if we can actually get this to happen. So the first part is I'm going to get cold. The way I'm going to get cold is I have a thing of ice water here. So I don't know if you can see the ice water. You just have to trust me. This is ice water. So there's that container. Then over here, I'm going to take this off of the hot pad over here. So this has been warming up. This is my container of hot water. So I don't know if you can see it. I can actually see steam coming off of that. So I don't know how well whether you can see that or not. So there's my hot water. If I take this and I put one end in the cold water and one end in the hot water, like so, what you should have is naturally heat is going to flow from this high temperature, which is my hot water, probably somewhere around 75 degrees Celsius. It's going to naturally want to flow from there into this system. And so my system is actually my little engine here, my electric motor. And then heat is also going to flow out to this cold reservoir. So my cold reservoir is a cup of ice water. So it should be pretty close to 0 degrees Celsius. So I've got 75 degrees Celsius, 0 degrees Celsius. I have a difference in temperature. Heat is naturally want to flow from one to the other. And they're using aluminum because it has a pretty high thermal conductivity. If I feel this side, I can tell that this side is already getting hot. And if I feel this side, I can feel that this side is already getting cold. So I have heat actually flowing through here. Right now, nothing's happened. But what I'm going to do is I'm going to flip this switch. Can you see what is happening? Notice that now my little propeller is spinning. I didn't add anything. I just have hot water and cold water. But by using that difference in high temperature and low temperature and using the second law of thermodynamics of heat flow, that heat naturally wants to flow, I should be able to get some work out of here. Am I going to get as much work out as I have heat flowing in? No. Thank you, Josh. Because I'm always going to lose something. One, I've got friction here when I'm trying to get this to spin. But also, one of the things of the second law of thermodynamics is you can't actually get a perfect conversion of all of your energy going in into work. That would break the second law of thermodynamics, because later on we're going to talk about Sadi Carnot, and he came up with the idea of a perfect engine. This is not a perfect engine. This is just a simple kind of idea. So I can flip the switch. It turns off, flip the switch, it comes back on. I always think this is just an amazing little demo because you're like, but it's just hot water and cold water, and I'm getting this little electric motor to spin. So I cool myself off in the middle of the summer, just get some hot